Okay, here we go. So getting real near the end. Today we are on day 3 of algebraic fractions. Next class we're going to continue our work with algebraic fractions, but we're going to be solving equations. Notice that we haven't done any equation solving for a while. All this work we've been doing has been taking fractions and simplifying them or adding them or multiplying them, but we're not solving anything until next class. Friday coming up is our last day of new material. Then Monday coming up is our last quest number 5, just on the new stuff with the fractions since the test. Wednesday, 1 week from today, is the last day of the semester. That's our review day in preparation for the exam a week from this coming Monday, 8 a.m. bright and early, right here. Questions on the calendar? Okay. So on page 85, we're going to see stuff that looks familiar because the problems today are just harder versions of the ones from last class. We're going to be adding and subtracting fractions today, same as last time. So first problem here is 5 over 6x cubed plus 7 over 8x. Step 1 for each of these is to factor all those denominators. Now there isn't anything to do here except maybe one thing. You could factor 6, right? 6 is really 2 times 3. And you could write out the x cubed, and it might seem silly, but I think it's worthwhile. So that's the one denominator. And then the other one is, instead of 8, 2 times 2 times 2. And then there's the x. Okay. And now our job is to fill in these circles, making sure we capture both of those denominators. But the important thing is the stuff they have in common goes in this overlapping part of the circles. So the first thing I see over there is a 2. Should we put that in the left, middle, or right? Middle, because there's a copy of a 2 over here. So the first thing I put is a 2. Next thing I see is a 3. Left, middle, or right? Left. 3 is the only one I see. It goes out there in the left only. Next thing I see is x. Left, middle, or right? It goes in the middle because there's an x in both. So I check the x in both. I put a single x there in the middle. Next thing I see is another x. Where does that guy go? That goes in the left because it doesn't have a counterpart on the right-hand side. I've already checked off the single x I had to play with. So I check this new x and I say you must go only in the left. How about the next x? That guy right there. Left. Finished everything over there. We'll come over to the blue. The first 2 is already taken care of. Where does the second 2 go? On the right. And then we'll check it. And then the last 2 also in the right. So that's how we write all these 2's and 3's and x's in the circles. Questions on that? Okay, and if you feel like you really want to check your work, you look at the first circle, which is just this part, and you multiply it all together. What do you get when you multiply those together? 6x to the third, which is exactly what we're saying. When you look at the right-hand circle and multiply those, what do you get? 8x, which is exactly what we wanted. Okay, so you could always look and make sure that you have it right. And so that means that the lowest common denominator is just the product of all these things. 3 times x times 2x times 2 times 2. You're welcome to smush those together, but I would leave it. I like leaving things factored, so it's going to be really clear to me in the next step exactly what each fraction is missing. Okay, and then we're rewriting the original fractions. Can somebody tell me what the first fraction was? 5 over, and then instead of 6x cubed, we're going to put the factored version that we wrote up above. We wrote 3 times 2 times x. That's what we wrote with the factored version, right? Put it back on the screen. I guess I swapped the 2 and the 3, but the thing that was purple, we're just copying it down there for the denominator. And then the other fraction What did it used to say? 7 over 8x, but instead of 8x, what color am I putting? Blue. So I'll just write that guy. 2 times 2 times 2 times x. Well, we're going to use it right now. So that step is me just rewriting those fractions, but putting them in a nicer form so that it's easy for me to tell what's missing in building the LCD. So let's look at that purple denominator. It's got a bunch of stuff in it. The goal is green. So we got to figure out exactly what's missing. And this is just a matter of carefully looking. Yeah, Lauren. We did. I mean, we never had x, x, x. Oftentimes we had stuff like x. Yeah, we did the original fraction, just the denominator. That's what we factored last time. Yeah. Okay, so look at the purple denominator, look at the green, and tell me what's missing to turn purple into green. It's just the 2 times 2 on the right-hand side. So I'm going to multiply here by 2 times 2 on the bottom, which will give me that denominator. And at the same time, what else do I do? 2 times 2 on the top. So there's our foo-foo. This isn't something we talked about last time, but does anybody see that 2 times 2 appearing elsewhere on this page? Where else is this 2 times 2? It's in the Venn diagram. You guys see it right there? Does it make sense to you that that's the stuff that's missing? That's everything that isn't in the first circle, right? The first circle is exactly the purple, and then we're filling in what's missing, which is whatever is over there. It's a nice little shortcut. I didn't mention it last time, but if you have a lot of practice with this, then you can start to kind of implement those shortcuts. Next denominator is currently blue. We're trying to turn it into the green. So we got to figure out what's missing to make blue become the green. Three times x times x. That's what we need. That way the denominator will become the green. And again, the 3xx is everything in only the first circle. Okay, and then immediately at the same time, copy it upstairs. Okay, so we've got our fractions. Remember we had said always multiply out on the top. So these are just numbers that are crunching together. So I think the first one becomes a 20 over. And then I said never multiply out on the bottom. But in this case, it's just annoying to write it all out, and it's just easier to write it in compressed form. I guess what I really mean to say, never distribute on the bottom. Like if the bottom is something that you might distribute on, don't. Like it's just going to make it bigger. But here, this isn't distributing, right? This is just kind of grouping and writing things more efficiently. So what is the denominator here when you mush them all together? 24 x to the third. That's all the stuff downstairs. It's just more convenient to write that than to write everything. Okay, upstairs on the other fraction, just mush stuff together. What do we get? 21x squared. And how about this denominator again, smushed together? Same, 24x cubed. And in the original problem, was it adding or subtracting these? Adding. So a plus sign right in the middle. Is the following valid or not valid? Cancel those x squareds, cancel these x cubes. You have a single x left over on the bottom. Valid or not? No? You're allowed to cancel when you have what operation? Only multiplication is when you're allowed to cancel. We don't have any adding and subtracting, so it's totally legal to cancel those things. Should we cancel those things? No, why not? To have the same denominator, you did all that work to get the same denominator. So even though it's allowed to cancel them, maybe you have an urge to cancel them, don't. You did work to make the same denominator. Now that they have the same denominator, we can make one fraction with one copy of that denominator. And then upstairs, just copying them, but in one numerator. I'm going to put some extra parentheses. They aren't mandatory, but sometimes they are. So I think I mentioned last time, just put them anytime you're mushing the two numerators together to make one. And that's it. These terms don't combine. There's no way to factor on the top. So we're done. Questions on that one? Okay, so when you're ready, let's move on to the next page. We're going to do two more examples together, and then you guys will spend the bulk of today just practicing in your groups. So the next one has slightly more complicated denominators than before, but the technique is always the same. You factor the bottom. X squared minus 9, I'm hoping we recognize this pattern by now. That is x squared minus 9 factor. X plus 3, x minus 3. So that's that denominator factored. Different kind of factoring here. This one we can pull something out of both. 2. And we're left with x plus 3. Okay, then we start filling in the stuff in the circles. You cannot pick and choose. You cannot go inside of parentheses. Anything in parentheses is one entity that can't be broken up. So the first thing I see is x plus 3, one thing. Where does it go? Left, middle, or right? Middle, because there's an x plus 3 in both. It was in parentheses before. Keep it in parentheses in that circle. Which of the x plus 3 should I check off? Both of them, because we just put it in the middle. It's in both circles. Next thing I see is x minus 3, left, middle, or right. Left, it's only in the left. Check that one off. Last thing we see is a 2, left, middle, or right. It's going to go on the right. So the LCD is just the product of those things written out just the way it looks. Next thing is copying those original fractions. What was the first one originally? I think you're on the wrong one. Good. Instead of x squared minus 9, what are we going to put? That's right. So just the thing we had written up there in blue. Just copying the fractions, but give them the factored versions of the denominators. What was the other fraction? Okay, and instead of 2x plus 6, that was the red factoring. Next step is to take these denominators and make them green. We need the entire LCD. Comparing blue to green, what's missing? Just the 2. So I'll multiply the bottom by 2 because that's going to give us the right denominator. Simultaneously, we multiply the top by 2 because we have to. Looking at red, trying to make it green. What's missing? X minus 3 in parentheses, top and bottom. Any questions on that step where we bring in the missing piece? Okay, here's a kind of funny step where we treat numerator and denominator completely differently. One of them we always multiply and the other one we never do. Which one do we have to multiply? It's the top. So upstairs, I see -9 times 2. That's -18. Downstairs, I'm just copying. I'm not distributing, not multiplying. So it's just that. Oh, I didn't mean to shuffle the 2 to the front. You can write them in any order, but I meant to just copy it. Okay, and then the other numerator, what do I have to do up here? The x and the x minus 3, got to distribute. So that becomes x squared minus 3x. Any questions so far? Originally, was it a plus or minus in between the 2 fractions? Plus. So copy the plus. What do you notice about the denominators? They're the same. That's why we built them. So that means that we get to bring these 2 guys together, one denominator. So copy either one. And then upstairs, we're just mushing the 2 denominators together. I'm actually just rewriting them. -18 plus x squared minus 3x. This is going to get me the right answer, but I am missing something that I want to put in, because sometimes I won't get the right answer. This parentheses. The moment you bring these 2 guys together, you are losing the fact that, for example, this thing was one entity. You could tell because it was by itself on top of a fraction line. But all of a sudden, it looks like it's exactly treated the same way as the -18 here. So you won't get this one wrong without parentheses. But if this had been a subtraction problem, you'd get it wrong without the parentheses. Safest thing, just bring those parentheses in at this moment every time. Okay, do any of the terms upstairs cancel? Or combine, I should say. We have x squareds, x's, and a number. Nothing to do. I'm just going to shuffle the order around so that it looks normal to me. You guys remember we talked about standard form or standard order for these guys? We would always write the x squared first, and then the x, and then the number. At this stage, is there anything you can cancel? For example, the 18 and the 2. Why not? There's subtraction. Of the 18 and the 2, one of them is cancelable, but the other one isn't. Which one is cancelable? There's the 2, because the 2 is next to a multiplication. But the 18 you can't do anything with. So oftentimes this would be our final answer, but there is something else we have to check. And that's to see if we can turn the top, which is currently subtraction, not friendly, into multiplication, which would be friendly. And what do we do to see if we can, how do we turn the top into multiplication, this factor? So the top looks like a regular old quadratic with all 3 terms. So I'm starting with an empty shell of 2 sets of parentheses. Remember, this is the whole product sum business. 2 numbers whose product is -18 and whose sum is -3. Alan says -6 and +3 will work. Agree or disagree? If you multiply those, what do you get? If you multiply -6 and +3, -18, that's what I want. If we add them, -3. This works. So then the final step here is to do what? Cancel. What cancels? X + 3 here and here. So just write what's remaining and you're done. Questions on that one? Abby? I didn't mean to move stuff. This one I definitely moved stuff around because I wanted it to look standard order. Yeah, I think I meant to keep things exactly where they were. Other questions on this one? Victor? Mm-hmm. That's exactly what we're doing. Figure out what's missing from the denominator and multiply that top and bottom. And then simplify, combine, cancel. Yeah, that's it in a nutshell. One thing I got to warn you about here, if you skip over the first step, which was this factoring, and you just say, oh, okay, I'm just going to multiply, I'm going to multiply this guy by 2x + 6, which is the other denominator. And I'm going to multiply this one here by x squared - 9. If you just don't recognize that they factor, then you are finding a common denominator, but you're not finding the smallest common denominator. And I'll also say that you are making the problem much bigger than it needed to be because you are now multiplying over here, this guy, 2x + 6 on the top. So you got to do some extra distributing over here. We didn't do that before. You're also going to need to do some more distributing over here. That and that. It's not that big a deal. It's a tiny bit more work. That's not why I need you to factor first. I need you to factor first because if you do this, what do you get when you distribute that x to the first term? X cubed, which should send shivers down your spine because the only thing we have experience with is x squared, right? And so when you come down here and you do this distributing, you'll end up with x cubed plus and then some other terms that are smaller degree, smaller power. And it's going to turn out that that thing factors, the x cubed part factors. The problem is that in this class we have no idea how to do that. Yes? I haven't given you anything with an x cubed in it to factor because we don't have the tools to factor it. So it's not wrong to just say, okay, I'm going to multiply the two denominators together. But you could be heading in a direction that leads you to a dead end based on the tools that we have in this class. That's why it's important to factor first. Okay, so there's one more here we were going to do together. How about you guys just, and then the group work is on the next page. Why don't you guys just start the group work now with this problem right here? I'll put the answer up in just a minute. So as you work through this, if you could tell me whether or not my answer on the board is right. I just did it now, and there's a chance I'll make a mistake. Haven't made a mistake in 7 years, but maybe I'm due. Oh, I like that. Hello. Okay, this is perfect. This guy right here, you have to distribute the -2. Oh, I've just written the final answer. So you have more work to do, but you have to distribute that -2 into that. Yeah, -2m minus 8 is what we get when we distribute that. That's correct. It's just in the different order from what it says. That's just m. Okay. And then this, is it there?